All right, Dima, all you.
All right. Thank you, David. Thanks, Kevin. Okay, so we are going to start talking today about the flood threat bulletin itself, which is kind of the main product that the program was built on, and the one that provides that daily um, snapshot of the next 24 hours in terms of the flood threat that we can expect. And so we kind of broke it up into a number of different sections. And to start off with, we're just going to talk a little bit about an overview of Colorado heavy rainfall and flooding history, as well as just some climatology. So we're actually going to start with a little bit of a twist. We're going to start with the snowpack because we all hear that the snowpack dominates our hydrologic cycle. And so what does that mean really? And I think this chart is a great example of what that means. So this is actually taking from the Rio Grande Basin. So the blue line shows the average stream flow at Del Norte, which is around 8,000 feet. So pretty far down from where most of the snowpack sits most of the winter. And then that's the blue line. The blue bars that you can see kind of piling up from October through April is the snow water equivalent at one of the NRCS SNOTEL sites at Middle Creek, which is around 11,000 feet. So this, I think what the point of this chart is to show that what we mean when we say that a basin is dominated by snowmelt is that you can see that in the wintertime, the average flow is a couple of hundred CFS, whereas when we hit that peak flow, the average peak flow during the spring and summer months, we get all the way up to 3,500 CFS. So essentially a tenfold jump. And then the other interesting thing to point out here is that we don't, in this particular basin, we actually don't see any more spikes in the flow once it hits its peak somewhere around early June. Say come July and August, all we see is a steady decline on average. And that we'll talk a lot about why that's the case. But so this is an example of a typical basin in the higher terrain of Colorado, which is dominated by snowmelt. And so now we're going to step through and talk about a different basin. So now we're focusing on a much smaller basin. This is the Fountain Creek Basin. This is the site just north of Pueblo, where the Fountain Creek comes into the Arkansas. And what we see is that it's a quite different picture. Even though Fountain Creek, the basin, has higher terrain with it that has a snowpack, we don't really see that much of a snow melt on average. We see a little bit of a spike from about 100 to 200 CFS from April to May, and then kind of a slow decline. And then interestingly, what we see is another spike in August, and that actually is the monsoon season. And so it's surprisingly hard to find these monsoon season spikes if you look anywhere across the state. And of course, the reason for that is because our climate is dominated by these kind of shorter term heavy rainfall events that don't really impact major river basins, with obvious exceptions like the 2013 event and other events we'll discuss, but those are super rare. And so the vast majority of the cases that we deal with in the flood threat bulletin are those marginal kind of conditional events that could target a smaller basin, but really don't impact particularly huge areas at once. So let's step forward here. So now we're going to talk a little bit about the seasonality of precipitation in Colorado. So our forecast season runs from May 1st through September 30th. And the reason why that is because that essentially covers the vast majority of heavy rainfall potential events, as well as snow melt, in fact, across the whole state. So we are showing these graphics from the Colorado Climate Center, and they have a really nice set of data when it comes to anything related to precipitation. And they actually have networks of precipitation gauges that we use. So what you see in these plots are average precipitation by month using a gridded data set from, I think it's from PRISM, the Oregon State PRISM data set. And then you see overlaid on top of that individual sites. Those are the little black circles that you see. So a couple of things to point out here. First of all, you see a lot of seasonality. So essentially what we like to boil it down to is 2 seasons, 3 if you include snowmelt. So there's a snowmelt season, which is characterized by warming in the spring, which produces that hydrologic response that we showed in the Rio Grande Basin and across obviously all of the mountain basins. So then we have a kind of a springtime, what we refer to as a jet stream dynamics driven heavy rainfall season. And that usually goes from May through about June. And those situations are where you're dealing with, excuse me, you're dealing with marginal moisture, but very strong dynamics that could generate generally kind of short term, let's say 60 to 90 minute heavy rainfall and associated flash flood threat. So the interesting thing is when you transition across June, and it's hard to see this when you're just looking at the monthly averages. So let's actually step forward 1 slide, Alyssa. And this shows it a little bit better. So this shows the precipitation chances at Colorado Springs. And what you can see is there are 2 humps. This is shown for different thresholds. So for example, the top line is the probability of seeing a trace of rainfall on any given day from January 1st through December 31st. And what I was referring to in the previous slide is that you see 2 humps essentially. You see 1 hump in roughly in early to middle May, and then you see a second hump in middle of July. And so that's what I mean when the earlier hump is what we refer to as that jet stream dynamics driven rainfall. And then the secondary hump in July, what we're heading into pretty soon here, is going to be driven by monsoonal moisture, which is basically where you have a lot of moisture, but you have limited dynamical forcing. And so it's a different beast in terms of heavy rainfall potential. But so I guess the takeaway here is that we have these 2 seasons separated by this temporary lull in June, and the temporary lull sometimes just doesn't happen. And like we saw this year kind of got going right away with areas that don't typically see heavy rainfall in the middle of June seeing it. And I'm referring to the southwest part of the state. So fantastic news down there with that drought situation. So I guess these 2 slides were meant to convey the seasonality. And then in terms of numbers, let's talk some numbers for what we typically see for heavy rainfall potential. So what we're showing here is the NOAA Atlas 14 recurrence interval rainfall intensity. We're showing 2 different durations. So on the left map, you see the 60-minute duration, and on the right map, you see the 24-hour duration. And I apologize about the colors, but they're actually, they're different legends to each map. So please refer to those legends separately. So if we first focus on the 60-minute duration, what we see is quite a range across the state where a 60-minute, so this is a 100-year event, I should note. So 1 in a 100-year event, or 1% recurrence potential. And so that event amounts to less than 1 inch per hour along and west of the Continental Divide. Essentially, especially the higher you go, the less moisture you typically have. So you do see lower rainfall intensities. So 1 inch an hour roughly is your 60-minute duration event. Oh, I'm sorry, your 100-year event for central and western Colorado. Whereas if we move eastward towards the northeast and southeast plains, that goes quite a bit upward into the 2.5 to 3 to even 3.5 inch per hour intensity. So quite the range that we have to cover. So, and again, the 60-minute duration, if you think about what kind of storm that represents, that represents your typical kind of like, let's say, conditional event where you have instability, and so you have a storm pop, and it can last for anywhere from 30 to 90 minutes, and the vast majority of its rainfall is going to come in that 30 to 60-minute time frame, and then it either dissipates or moves on to different locations. So when we step out and talk about the 24-hour duration, things change a little bit. We still see that variance across the state, where the western part is generally drier than the eastern part. And just to throw out some values, so out west and over the central part of the state, a typical 1% event for the 24-hour duration is going to be somewhere in the 1.5 to 2 inch range. And then once you move to the east, it's going to be higher into, let's say, the 3, 4, and even the 5 inch over 24-hour accumulation range. Now, the one interesting thing to point out, and you can see this both in the 60-minute and the 24-hour durations, is that along the front range, essentially, actually really along the whole I-25 corridor and just to the west, you see a local maximum in the values, the rainfall intensities, and that is a really interesting effect that is driven by our very unique topography. So essentially, you'll hear us refer to this over and over again, that our topography is so unusual compared to the rest of the United States, and really most places in the world, because we have the higher terrain. It drives its own circulation, and so what you're seeing here with these bullseyes is essentially storms getting anchored to the mountains, and we see this right along those foothills, south of the Cheyenne Ridge, south of the Palmer Ridge, and again in the wet mountains. So really interesting features that are very microclimate driven. So let's step forward one slide.